So guys, Compton effect. Compton effect is a confirmation of the photon model of light, or we can say the particle nature of light, or it is a confirmation to the quantum theory of light. So according to the quantum theory of light, photons behaves like particles except for their lack of rest mass. How far this analogy can be carried? For instance, can we consider the collision between a photon and an electron as if both were billiard balls? So, taking this analogy, we are going to find the results of a collision between a moving photon and an electron which stays in rest. And we are going to check this result by the actual experiment. Okay, actually this experiment is done by the scientist called Arthur Compton in 1920s, and the phenomenon is found to be correct, and thus it is called Compton effect. So here comes a photon and here stays our electron. So after the hitting, photon goes in this way and electrons moves in this way. Okay, so any energy that gained by this electron is the energy that lose by this photon. Since we take these two particles as a whole system, and since there is no other forces acting on the system, the total energy gained by this electron will be equal to the energy lost by this photon. Okay, so the energy lost by the photon is equal to the kinetic energy gained by the electron. So, since the photon has an energy h nu, and we consider that the reflected photon has an energy h nu dash, and this nu dash is its new frequency, and it makes an angle phi with the horizontal, and this electron makes an angle theta with the horizontal. So the energy lost by the photon can be represented as h nu minus h nu dash, and which is equal to the kinetic energy gained by the electron. And to solve a problem which involves the collision of two particles can be easily solved by applying two conservation laws, that is the conservation of energy and the conservation of momentum. In every problem which involves an elastic collision can be solved by using these two conservation laws, and by the application of these two conservation laws makes the problem simpler. So here we are applied the conservation of energy, and now we are going to apply the conservation of momentum. We know for a massless particle like photon, energy is its momentum into its velocity, that is the velocity of light. So its momentum P will be is equal to E by C, and here energy of the photon E is equal to G of photon E is equal to h nu. So the momentum P will be h nu by C, and since we consider the two particles as a system, and since there is no force acting on this system, the total momentum will be conserved. In both three-dimensional coordinate system, the momentum of this system will be conserved. Okay, so initial momentum P initial is equal to h nu by c. So we are taking this direction to be the momentum in y direction to be h nu dash by c, and momentum in x direction to be dash by c sin phi, and this x direction to be h nu dash by c cos phi. By applying, since momentum is a vector, by applying vector algebra, we can say the momentum in y direction is h nu dash by c sin phi, and the momentum in x direction is h nu dash by c cos phi. And this momentum in negative y direction is, by taking the particle momentum in this direction is p, that is p is equal to, that is p, momentum in this direction is p, and so momentum in the y direction is p sin phi, and momentum in the x direction is p cos phi. So by applying the conservation of momentum, P initial in the x direction is h nu by c, and P final in the x direction is h nu dash by c cos phi plus p cos phi. Since there is no other forces acting on this system, the center of mass of the system will remain at rest or at constant velocity. So by applying conservation of momentum, we can write that h nu by c is equal to h nu dash by c cos phi plus p cos phi, p cos theta, p cos theta, sin theta, p cos theta. And same as in y direction, since the particle moves in x direction, or the photon moves in x direction, there is no momentum in y direction at the initial case, so it is 0 conservation of momentum in x direction, and the conservation of momentum in y direction. By applying conservation of momentum in y direction, and the particle moves opposite in negative y direction, so it is minus p sin theta plus h nu dash by c, the positive y direction, so it is plus h nu dash by c sin phi, that is p sin theta is equal to h nu dash by c sin phi. So this is equation number 1, and this is equation number 2. So we can rewrite equation number 1 as p cos theta is equal to h nu by c minus h nu dash by c cos phi. Let it be equation number 3. So by doing algebraic method,